Hello students, today we will be starting with a new chapter that is conventional representation. Let's begin with the chapter. Now what is conventional representation? In engineering world, it is a common practice to represent various types of materials, various type of machine components, various machining processes, etc. by using a particular symbol. For example, you can see in this picture we have different machine parts such as here a suspension leaf spring, a compression spring, elbows, gears, some materials, external thread, internal thread, some machining operations like counter sun, counter bore, etc. As you can see in this figure represents the different machine parts as well as different types of materials. Then some operations like boring, countersink, counterbore, knurling, etc. So, in order to represent all these components or machining processes or materials, we use a particular symbol for each of them, and this symbol is nothing but the conventional representation of the various machine elements. For example, here this you can see workpiece is having diamond knurling on it. So in order to represent the knurling on the part, we use a particular symbol for that part, and then this itself is called as conventional representation. So now let's begin with the chapter. The first is conventional representation of materials. Now we will study how we can represent different materials used in the engineering world by using a particular symbol. Now first title is given as metals. Now here you can see in metals steel, cast iron, copper and its alloys, aluminium and its alloys, that is different materials are represented by using a particular symbol, and the symbol is given as in the figure we have a triangle rectangle inside which we have inclined line at 45 degree. So when you draw this rectangle with lines inclined at 45-degree, this will stand for the representation of the materials like steel, cast iron, etc. Similarly, for other materials like lead, zinc, tin, white metal, etc., we use this symbol. So in this symbol you can see there is a rectangle in which lines are inclined at 45 degree towards right as well as towards left. So when we use this symbol on a drawing or a sheet or a production sheet, this symbol will indicate the materials like lead, zinc, tin, white metal, etc. Now the next symbol for the glass. Now glass is represented by this picture. You can see it is having lines inside it. That is, you have to draw a rectangle and then you have to draw parallel lines inside it of different lengths. Similarly, in order to represent different packing and insulating materials like porcelain, stoneware, marble, etc., we use this symbol. You can see in this figure the lines are inclined at 45 degree and they are having spaces in between them. So this symbol when used on a production drawing will indicate the packing material like porcelain, stoneware, marble, etc. Similarly, insulating material like asbestos fiber, felt, synthetic resin, paper, cork, rubber, leather, wax, etc. are represented by this symbol. In this symbol, we have a rectangle in which horizontal lines are drawn parallel to each other as well as there are lines inclined at 45 degree to the horizontal line. So when we show this symbol or this representation on the sheet, it will represent the conventional representation of the insulating material. Similarly, for different types of liquids like water, oil, petrol, kerosene, etc., we use this symbol in which a rectangle is present and inside it we have to draw dotted lines by followed by a straight continuous line. This symbol will represent different types of liquids. Similarly, for wood, we have the symbol here. This symbol will represent the conventional representation of wood and plywood. And last, the material is concrete. For representing concrete, that is mixture of cement, sand, and gravel, we use this symbol. In this, you can see there is a rectangle having number of dots, and these larger dots are nothing but the gravels. So basically, in order to represent different types of materials which can be steel, lead, glass, wood, mixture of cement, anything, we have a different symbol for each of them. And these symbols are nothing, or these diagrams are nothing but the conventional representation for the different materials. Now next, we will see conventional represent of pipe joints and walls. In order to represent pipe joints and walls, we have conventional symbols. Let us see the symbols one by one. First, you can see it is a socket joint. This part, the center part is nothing but the socket. It is having two internal recesses for fitting pipes. One pipe will be fitted on one end and the second pipe will be fitted on the other end. So whenever two pipes are to be aligned in such a way that that axis is collinear, then we use a socket joint, and the resulting we will get a pipe connection using a socket joint. Similarly, the next you can see is bend. Now, bend is an integral of pipe, integral part of any pipe. So, if a bend is to be drawn in a pipe, it should be represented by this symbol. So, this symbol is used to represent bend, or this is a conventional symbol for bends. Now, elbow. Now, elbows are basically used as well as bends. They are used to change the direction of the flow. If you are to change the direction of the flow by some angle, that is by 90 degree or 45 degree or 60 degree, you can use bends and elbows. Bend is an integral part of a pipe, but elbow is not an integral part. It is an external part which is fitted on a pipe. Now the fourth is reducing socket. Now you can see that this socket is having two diameters, one larger diameter and one is minimum or lower diameter. So if we have two pipes of different diameters in which one diameter is larger than the other, then we can use the reducing socket. The reducing socket will reduce the flow area. If the liquid is flowing through the socket, then as the liquid passes from section 1 to here is section 2, the velocity of the liquid will increase as the cross section is reduced. So we can here connect two pipes of different diameters. Larger pipe will be connected on the left hand side, whereas smaller pipe can be connected on the right hand side. The next is nipple joint pipe. Similarly, as is same as socket joint. This is used to connect two pipes together. And the next is T joint. Now, as clear from the figure, you can see if we want to connect three pipes together, then we can use a T joint. It is having three holes, first hole on the left side, second hole on the right side, and the third hole will be on the bottom. So the main flow of the liquid will occur from this side, and then it will be diverted in two directions, one on left side and one on right side. So basically we can connect three pipes together by using a T joint. But if you want to connect four pipes together, we can use cross joint instead of T joint. So here the flow will be change in or the flow of the liquid will be happening in three directions. The inlet first, the fluid will enter from the bottom, that is here, and then it will be diverted in three different directions, one on the left, one on the right, and one on the top. So basically all these pipe joints are represented by using a symbol. So if we want to show some type of joints on a drawing sheet, we will use different types of symbols, conventional representations for elbow, bend, etc. Now next we will see conventional representation of machine operations. Now how we can represent different machine operations using symbols. Now you can see this is my workpiece which is having a board inside, there is a hole. So this diagram will represent the conventional representation for boring operation. So if you want to tell the operator that a bore has to be done on the workpiece, then this type of symbol should be drawn on the production drawing, which will indicate that the component is to be bored. Similarly, countersunk. Now you can see countersink, there is a recessed hole at the bottom and a recess in the conical form is created on the top. The reason is that when we insert a screw having a tapered head, that is conical head, then as soon as we enter the screw inside this part, the lower part, that is shank of the screw, will fit inside this hole, whereas the upper part will contain the head of the screw. So in order to locate the screw properly, we use countersunk, and to represent the countersunk operation, we use the symbol as shown in the figure. Counter bore. Now, in the first diagram, we have seen that a bore was made. But if we want to enlarge this bore from one side, then this operation is called as counter boring. So, in order to do counter boring, first we create a bore of particular diameter, and then we enlarge this hole again by using certain boring tools. So, counter bore. Again, this top recess will help or will provide a seat to the head of the nut or the bolt or the screw. Facing. Now, what is facing? Facing is basically done to make the surface of a workpiece flat. So, whenever facing has to be done on a workpiece, this symbol will be drawn on the production drawing. So, that will indicate that facing operation has to be performed on the workpiece. Board and recess. The conventional representation of boring and recessing is this. So whenever this symbol is present on the production drawing, this will indicate that the component has to be workpiece has to be bored and then it has to be reset. Similarly, for fillet male radius or female radius, we use this type of symbols. Number eight is chamfering. Now, why chamfering is done? After some machining process has been performed on the machining, the edges of the workpiece are sharp, so they may lead to injury while performing some quality operations on the workpiece or while shifting the workpiece from one location to the other. So, in order to prevent the injury, the sharp edges of the workpiece are eliminated or cut. So, you can see here, this was the sharp edge passing through the corner. This was my original workpiece and this was the corner. So, in order to remove this corner, the face or the edge is cut by some angle, basically 45 degree or 30 degree, and then the upper part is removed. So, we get a surface that does not contain any sharp edges. So chamfering is basically done to remove sharp edges so as to prevent injury as well as to distribute the stresses. Beveling. Now when one surface or any one surface of the object has to be inclined, then we perform the beveling operations. You can see for beveling we use this conventional representation. So in order to represent the different machine operations like counter bore, counter sum, boring, male radius, female radius, chamfering, etc., we use these type of symbols. So these are nothing but the conventional representation of the machine operations. Now conventional representation of brakes in pipe and rod. Now consider that you have a rod of length 1 meter or length 2 meter, that it will not be possible to represent the rod on the drawing sheet with actual dimensions as the diameter is very large or the length can be also be large. So in order to avoid this problem, we represent the same pipe or the same rod or the shaft by using the conventional symbols. So first you can see round section. Here we have a circular rod or circular shaft. In order to draw this shaft on the drawing, we break it from the center or we can break it from the middle. So this drawing is nothing but the conventional representation of a round section or a round shaft, and the symbol is here circle with the center lines. Similarly, for pipe and tubing, we can use these two symbols. So these two symbols represent nothing but the pipes or tubes which are having some internal diameter and an external diameter. Then in order to denote rectangular section, for example, we have a shaft whose cross section is a rectangle in shape. So in order to denote the rectangular section, we use this symbol. That is, we will draw a shaft or rectangle and then we will show some hatching lines with the break, and in the symbol we will use a rectangle. Similarly, for showing a rectangular section for wood, we use this symbol. So these are the various symbols which are used to represent the brakes or the large diameter rods or pipes or shafts. For I section, this is the symbol used. Similarly, for C section, we use the C shape, and for T section also we use the T shape. So these basically are all the conventional representations of the tubes, pipes, rectangular sections, I section, T section, channel section, etc. Now we will see the next topic, conventional representation of springs. Now students, springs are basically used to absorb shock, or they are told as shock absorbers or less shock absorbers. So in springs we have different types of springs. There's compression springs which will take the compressive load, tension spring which will take the tension load, as well as we have different types of release springs. So we will see all the springs one by one. The first is the tension spring. So in this figure, that is figure 1, it is the real or the pictorial view of a tension spring which is having its cross section as cylindrical. So this is a cylindrical helical tension spring of wire of circular cross section. If we cut this spring from here, we can see in the side view a circle, that is its cross section is nothing but a circle. In order to represent the tension spring by using diagram, we have drawn a simplified diagram. That is, this diagram whenever drawn on the production drawing will indicate a tension spring. Next is leaf springs. Now leaf springs are used when the load or the shock absorbed is high. You can see that leaf springs are basically used in heavy vehicles like trucks, then four wheelers also. This is because they have large shock absorbing capacity. In springs, in leaf springs also, we have different categories. First, we can see semi-elliptical leaf spring. You can see in leaf spring there are number of bands, or we can say number of rods which are in the shape of semi-elliptical shape. That is, if we cut these bands from the across the cross section, you can see a semi-elliptical shape. So it is called a semi-elliptical leaf spring. Now there are many types of semi-elliptical leaf spring. In the first, only a simple leaf spring is shown without any high hole and center band. In the second, we can see this leaf spring is having a eye holes. Now these eye holes are provided for mounting. Similarly, in third, we can see all the leaf springs are tightened together by using a band, that is a center band, so that all the positions of all these springs remain fixed with respect to each other. And the last is a spring, semi-elliptical leaf spring, which is having both the center band as well as the holes for mounting. And this is the symbol for the different other semi-elliptical leaf springs. For example, if we want to draw or to represent only a simple semi-elliptical leaf spring without eye holes or center band, we will use this figure. So this figure represents a semi-elliptical leaf spring without center band and eye holes. And the next is having eye holes, and these eye holes are used for mounting the spring on the vehicle. Center band in this spring is having only center band, no eye holes, so that all the bands are tightened together. And in the last, we have a semi-elliptical spring which is having eye holes for mounting as well as the center band, so as to make the location of all the bands fixed in respect to each other. Compression springs. Now, compression springs are basically are used for absorbing compressive loads. That is, these springs will absorb the compressive shocks. Now, in compression springs also we have different types of springs. You can see first two is this and this are both are cylindrical helical compression spring or wire of circular cross section. This spring as well as this spring are cylindrical, whereas this spring, this is the last one, is in conical in form. You can see from the top the diameter is minimum and at the bottom the diameter is maximum. So in this case, in this type of spring, this diameter goes on increasing gradually. But in the first two type, that is first and second, the diameter remains constant. So they are cylindrical in shape, whereas they are said to be conical in shape. Now the section may cross section of the spring may vary. In the first case, this spring is having its cross section as a circle, so a symbol phi is indicated. So whenever you are to represent a cylindrical compression spring having circular section cross section, we will draw this figure and then we will show a symbol phi to indicate the circular diameter. In the second case, again we have compression spring, but in this case the cross section of the spring is not circular, it will be a square, so it is called as or rectangular, a wire of rectangular cross section. So this is the actual view of the spring, cylindrical helical spring without any section. This is with section, and this is the conventional representation of the spring. Now, why we use the conventional representation? If we want to draw the spring on a drawing or a production drawing, a very time consuming process, because we have to draw these two projections in two tracking. So in order to reduce the time, we use the simplified representation of the components. So for drawing these symbols, it will take much lesser time and will be useful to indicate all the information is required by the operator, which is who is working on the machine. Conventional representation of common features. Now, in order to represent different machine components, we again use some symbols, that is conventional representation. For example, if you want to show a slotted head, this is a screw, the lower part is the shank and the upper part is the head. Now on this head a slot is created so that it can be tightened properly. This slot is provided for tightening the screw on the workpiece. So in order to represent the slotted head or to show the slot on the head of the screw, we use this symbol. In this you have to draw a circle and then we have to draw two inclined lines which are parallel to each other and at a 45-degree with the horizontal. In order to show the radial ribs, we use this symbol. Ribs are provided to provide the support to the workpiece. Whenever one part is to be supported on the other part, then we use ribs. So ribs are basically used for supports or to provide extra strength. For ribs, we use this symbol. Serrated shaft and spline shaft. Now In order to represent the shaft, which can be either serrated or splined, we use these symbols. Now, why these positions are provided on the spline shaft or the serrated shaft? If you want to fit a key or fit another shaft on this type of shaft along with a relative motion, then we use the spline shaft. So these projections or the cuts are provided so that we can fit another type of shaft or keys on these two shafts. And to represent the serrated shaft or spline shaft, we use this symbol. So basically, if you want to represent a slotted head on a diagram on a drawing sheet, we will represent it by a conventional symbol as shown here. Similarly, if you want to represent serrated shaft, we will use these symbols. Because if we draw the actual projection with the true dimensions of these parts, the serrated shaft, radial ribs, it will be a very time consuming process. So, in order to reduce the time, we use the conventional representation of the parts. Now the next is bearings. Now in order to represent the bearings, either ball bearings, cylindrical bearings, we use the symbol as shown in the figure. So this is the actual view of a bearing and this is the conventional symbol of the bearing. So if you want to represent the bearing on a production sheet, then we will use this symbol. The next is straight knurling and diamond knurling. Now knurling is basically done on the workpieces to provide grip. So in order to provide grip, we have to perform knurling. Now which type of knurling has to be performed, that can be shown with the help of the symbols. For example, if the workpiece has to be done with the straight knurling, then we will use this symbol. So this representation is nothing but will indicate that the a straight knurling has to be performed on the job, and this symbol that is at the bottom will represent the process for diamond knurling. This will indicate that a diamond knurling operation has to be performed on the workpiece. So these three symbols are basically used for bearings, straight knurling and diamond knurling. And the last we can see here conventional representation of taper. Now in order to indicate taper on a drawing, we use a symbol. You can see here this is a workpiece. The major diameter or the larger diameter is D and the smaller diameter is D, small d, and the length of the workpiece is L, and this is a tapered workpiece. In order to indicate this tapered workpiece with the help of a symbol, we will use this symbol, that is a triangle. So this triangle, whenever used on a production drawing on a drawing sheet, will indicate that a tapering operation has to be performed on the workpiece. So basically different types of conventional symbols are used for different machining operations, for different materials, for different machine parts, etc. Because they help to represent the same component and are less time consuming to draw compared to the original projections.